episode 6 of Everybuddies podcast, and we are now broadcasting our pirate code and hacking into the Matrix. Everybody's podcast coming straight at you from Burnsville, Minnesota. Have you heard? So go ahead and open up you have it open. What do you see there?
Bunch of alcohol basically thrown off the shelf.
Yeah, it's actually a liquor store in Virginia. And all that alcohol you see on the floor is off the bottom shelf.
Okay.
Someone came in through the roof, crashed through a ceiling tile, and then destroyed a bunch of liquor bottles on the bottom shelf. And if you go to the next slide, you can see.
Did it?
Yeah, they found a raccoon passed out in the bathroom drunk.
Okay. That's my next question. Was it consuming the alcohol?
Yeah, it was consuming. I imagine, that. So on the floor there, you can see a bunch of hard liquor, but there has to have been something sugary too, because wild animals just don't usually go for distilled.
Straight up alcohol. No, elephants will go to villages and drink all the rice wine, but that has nutrition in it as well as the alcohol. And they'll tear up whole villages.
Really?
Like displace people. Yes.
In order to get at the rice wine?
Yeah.
No way. I guess that would have to be in India, or it would have to be in Southeast Asia, because I don't know if rice wine is a thing in Africa. If you go to the next slide, this is actually from Springfield, Ohio, and what happened was this lady's car was just kind of out in the street, and an officer went up to it because tags were expired. When he looked up the owner, she had a suspended license. The car was just kind of parked on the side of the street, and he looks in, and he finds that raccoon there.
With a pipe.
Sucking on a meth pipe. Click that photo of it. When they searched the car, they found meth and crack and everything else in there. The lady there on the left was the owner of the car, owner of the vehicle. She's 55. It's a hard 55, man.
Yeah. The issue will be proof that she put those drugs in there.
Can you prove they were hers?
Yeah, especially if the car looked abandoned on the side of the road.
Okay.
And then you have an actor in there.
Oh, so actually that was her pet. It turned out that was her pet raccoon. It learned by observation. Right. Shall we look at some comments?
Supernova explain neutrino trapping in core bounce. How does spin become a neutrino?
So that's a fair question. That is Sad Bob 2356.
Yeah.
That's actually a fair question. So that video, that clip, I was talking about how there's a couple different ideas, a couple of different working hypotheses about how supernovae are actually formed, how they actually occur, why the explosion itself happens. And one of the most prominent theoretical ideas is that you have a whole bunch of electrons that are forced into the nuclei of their atoms near the center of the star, at the core of the star. And when those electrons are forced in, they merge with the protons and become neutrons. In that process, a lot of energy is released, momentum is released, right. And that momentum is released as neutrinos.
Isn't there more quarks in the sum of a proton and an electron than quarks in a neutron? No?
It's actually the same number of
Okay.
quarks. It's 3. It's 3 quarks in a proton and 3 quarks in a neutron. Electrons,
that's what I was saying.
Electrons are not made of quarks. They're leptons. They're primary particles in themselves. If you go to the next slide, I have a little thing showing the standard model of elementary particles. So if you look there, you can see that there's up quarks and down quarks. So all the matter we deal with, all the baryonic matter we deal with, is made up of up quarks, down quarks, and electrons. So when you talk about charm and strange and top and bottom and muon and tau, those are actually too heavy to exist for very long in our universe. They're too heavy to be stable. They break down quickly. If you look in the upper left-hand corner of each one of those little squares, so like if you look in the upper left-hand corner of the up quark, you can see it's 2.2 mega electron volts per centimeter squared. But if you look at the charm quark right next to it, it's 1.2 giga electron volts per centimeter squared.
Or is that the speed of light?
Ooh, that's fair. That's a fair
'Cause
question. Okay, divided by the speed of light squared. Yes, you're right. So the thing is, you can see that the charm quark is 1,000 times. It's basically 3 orders of magnitude heavier. And with the top quark, it's another 2 orders of magnitude
So 5.
beyond that. And it's the same, like if you look at the electron neutrino and the muon neutrino, that the muon neutrino is actually much, much larger. Like, what is that, about 3, 4?
No, it's way more.
Yeah, you're right.
No, more than that. The electron neutrino, it's saying it's less than 1 electron volt, and then it's saying the muon is 105 mega electron volts.
If you look at the electron neutrino and the muon neutrino,
Muon neutrino.
it's 0.17 mega electron volts, so about 170,000. So you basically have 5 orders of magnitude heavier with the muon neutrino. On the right, I have the mass of the proton, mass of the neutron, mass of the electron.
Yep.
So basically what it is, with the electron is zipping around in the outer band.
Okay.
And it has its own spin, right? So the proton has spin, the electron has spin. The electron is also zipping around at an extremely high speed. That's what the Bohr model of the atom would say, is that the electron is moving around at very high speed. That isn't actually what's going on, but it is a model that works, because as that electron gets pressed in further, it is, quote, moving faster and faster
Okay.
to keep from falling in. But then when it actually falls in, all that momentum has to become something. All that momentum has to be released somehow. So that's what's being released, is that electron spin plus its movement is being released as a neutrino.
Okay.
So another thing you can look at, if you look at the charge on the up and the down quarks, you can see that the up quark has 2/3 charge and the down quark has -1/3 charge.
Okay.
So a proton is 2 up quarks and 1 down quark. So
Okay.
4/3 minus 1/3.
Yeah, that's 1.
And then the neutron is the opposite. It's 2 down quarks and 1 up quark, which add up to 0 charge.
Okay.
So that electron is falling in,
Okay.
and that's how you get a neutron. But yes, that additional energy, that additional momentum from the electron, it has to be released. And it's released as a neutrino. Now that neutrino is very, very small, but they move somewhere between 97 and 99% of the speed of light, maybe even be more than that. We're not actually able to accurately enough measure it to say that there have been measurements that have shown them going faster than the speed of light. We know that theoretically that isn't possible. And in those experiments, it was actually found that there were problems with the equipment that led to a measurement faster than the speed of light. But another way to say it is, with any instrument, you have uncertainty. And we can't tell accurately enough what the speed, we cannot prove with the instrumentation we have that they're actually moving slower than the speed of light. Does that make sense?
Yeah.
Okay. All right. Anyway, the next comment.
Mitochondria and chlorophyll, the secrets of life explained. Shade 0W Walker said same, heart.
Yeah, that's where I said I wish I had chlorophyll.
That's wonderful.
At least I'm not the only one.
Yeah. I don't have much thoughts on that.
Oh, that's fine. Next one.
Pro-life, support children's care, a critical look. Savage Tomahawk says, need to stop treating abortion as a viable choice. It's the most irresponsible and damaging choice you could make. Condoms are cheap. Abstinence is free. Responsibility is a higher priority.
Okay.
I agree with what he says.
Okay.
Condoms are cheap. Abstinence is free. And as far as like treating abortion as a first choice, yeah, obviously. But I don't think anyone's choosing, I don't think anyone goes into having sex with someone saying, yeah, I'm just going to get an abortion after this.
So, go ahead.
Also, having a child completely changes the mother's body. And not all those changes are for the better, for her life.
Yeah, that's true. And honestly, it's not for you or me to judge which
Right.
of those changes should be desirable or not.
You're right.
Let's see. From a philosophical standpoint, I understand where Savage Tomahawk is coming from, because it is better to prevent problems. You know, you put on a seatbelt when you get in a car. And we actually have laws now because people didn't used to always do that, right? From a philosophical standpoint, I see where he's coming from and I agree with him to an extent. However, from a legal standpoint, it is not for me to tell a woman that she has to carry a child. That is, and quite frankly, it's not the government's business either. While I understand where Savage Tomahawk is coming from, which, by the way, that is a really cool name. Ultimately, I think we're just going to have to disagree with him, or I'm going to have to disagree.
Yeah, I disagree with holistically saying it can't be a choice.
Okay. If you want to hit escape and go to the other tab. So what this video is on, this is a video abstract of a study they did on children who were given smartphones. It's both children who had smartphones and children who didn't. And they looked at some things related to well-being of those children. And they specifically looked at children between 12 and 13 years old. So anyway, I'll let you continue with that.
Among American teens, when mid-adolescents or age 13 to 17, almost everyone has their own smartphone in the US, more than 95%. When we look at younger ages 11 to 12, more than 50%, almost 60% have their own smartphone. And when we go a bit younger to elementary school age, around a third of the kids have their own smartphone already by age 8 to 10. What we wanted to ask in this research is,
So what do you think about that? Where he's saying 90% of kids between 13 and 17 have their own smartphone.
Yeah, I think it's fairly well known that owning a smartphone from a young age is going to be problematic,
Okay.
which I think that's my hypothesis is that this is what they're going to say is that it is in some way negative.
Okay. When you were in high school,
Yeah.
did most people have a smartphone?
Yeah.
Okay.
I had a smartphone.
What percentage had a smartphone in your estimate?
I don't think I've met one.
Okay. And in your estimate, was it a net positive or a net negative?
I don't have a reference. I wasn't an outside observer.
Okay. Gotcha.
But I know like people like Mark Zuckerberg and Bill Gates, they don't let their kids.
I've heard social media people, like social media executives, saying they do not allow their kids to access social media.
And so I think most parents recognize that, but then you got to deal with your kid is in the out group if they don't have one.
Yeah, that's true.
And then you got to say, yeah, in an emergency situation, I'm just going to have to let them figure it out. Because even nowadays, like phone carriers, they are supporting fewer and fewer dumb phone options, like flip phones.
Really?
And like now, if you want a flip phone on Verizon, for instance, you basically have to get a smartphone that's in a flip phone package that still has all the functionalities of a smartphone.
Because nobody's making flip phones. anymore.
People are making them carriers,
It's not profitable,
forcibly
not as profitable.
obsoleting them.
Okay, because for the carrier, it makes sense for them to sell data,
Right.
not just a phone number connection. Huh. Okay. So you'd have to go probably to a smaller carrier or a secondary carrier.
I believe no.
Be someone who does it.
There's carriers that still do like 3G, but it's actually more expensive now for them to run 3G than it is for them to run 5G.
Okay.
5G and 4G.
Because those networks really just don't exist anymore.
Yeah, it's hard to do now.
20 years ago, when Obama was running for president, it was a big deal that he had a BlackBerry.
Yeah, use the BlackBerry phone.
Right, right. And people called them crackberries because they would get addictive. Like, so the BlackBerry, but it was just a phone with internet access, with like a little bit better screen and internet access. There weren't all kinds of apps for it. And social media, like as we know it, didn't exist. Like there was MySpace, but MySpace was kind of like a phone book, like an online phone book, almost. You'd like you could put up your site and your picture and play some music on it, but you didn't have a feed. It didn't automatically connect you. Like you would just tell people what your MySpace was. People could search each other, I guess. I didn't have a MySpace, but people could search each other and stuff. And there were a lot of music artists, like I know Luther Vandross, he actually found a whole nother market of people to buy his music, basically millennials. He was able to get millennials interested in his music through MySpace.
Okay.
But it was not, people weren't like scrolling MySpace. Now they're set up so you scroll and you scroll and you scroll.
Yeah. What I think this is going to say is having their own access is there's going to be a lot of detriments, and then they're going to label a few positives.
All right, hit the space.
Out. To do that, we analyze data from the adolescent brain cognitive development study, which is a national study that follows more than 10,000 kids from childhood to adolescence. It includes kids from across the country, 21 sites, and follows them annually. Now, the kids started the study with age 10, but in the first assessment when they were 12, the parents were asked whether the kids had a smartphone. And what we did is look at this exposure of traffic to their own smartphone with several or three outlets.
So how many kids did they say it was? Like more than 10,000, right?
10,000.
It was 10,000? A little over 10,000.
10,000.
Okay, gotcha. And basically it was the third year of the study. They started at age 10. And third year of the study, when they were 12, they asked, do they have a smartphone?
First thing we looked at was how common was smartphone ownership in this study. And we saw that, alike with the national data I showed you before, just over 60% of the kids by age 12 had their own smartphone. You can see on the right that the median age at which they received the smartphone was 11, with relatively nice distribution of the age of first ownership in the cohorts.
So at age 12, 60% had a smartphone.
Yes.
The median age at which they had received it was age 11.
Yeah.
Okay.
We did three different sets of analysis. We looked at three outcomes: depression, obesity, and insufficiency, defined as sleeping less than 9 hours a night. And we did three analyses. Analysis one looked at the exposure of owning a phone versus not owning a smartphone. Analysis two looked among the kids who owned the phone at the year of first acquiring the phone. And analysis 3 actually measured longitudinal data from age 12 to 13, looking only at kids or including only kids who by age 12 did not have a phone, comparing their health outcomes at age 13 of those who did compared to those who did not acquire a phone in their past.
Okay, so we're looking at three outcomes: obesity, depression, and how much sleep people are getting. If you're getting less than 9 hours of sleep at night at that age, you're getting too little.
Yeah.
And then what they looked at was everybody who had one at age 12. Then they looked at age of acquisition before age 12. And then they looked at, well, what about people who acquire a smartphone between age 12 and age 13? So there's three factors and three groups.
Okay.
All right.
We find First, that on the left in analysis one, only the smartphone in age 12 or by age 12 is associated with well-behaved outcomes across the board, no depression, no obesity, no insufficiency. And this was a significant for adjusting for age and sex on the one in blue, but also when further adjusting for multiple factors, including socio-demographic, socioeconomic, parental monitoring, pubertal development, and use of other devices. You see here on the right is that among the kids who already had a phone, the earlier age they had it, there was better outcomes, more obesity, and more insufficient sleep if you got your smartphone at younger age.
Yeah.
So he's saying here, the earlier they got it, the worse the outcomes were for these 3 points of measurement.
And it's pretty significant too. If you acquired that cell phone before age 12, you were, what, 50% more likely to be obese?
Understanding these graphs are a little...
Okay. Do you want me to look at it?
Go ahead.
Okay. Let me come over here with you. So, what this is showing, this odds ratio, is how much greater, how much more likely are you? And the orange part is where it's been adjusted for socioeconomic status and health status and all that. So if you look at your risk of depression, when you adjust for everything, kids who own smartphones at age 12 were 25% more likely to experience depression. They were 40% more likely to be obese.
Okay.
They were 60% more likely to be sleeping poorly at night.
Okay. And then the second graph here is for each year earlier than age
Right.
12.
Your risk of depression for every year before age 12 that you're owning a smartphone.
3 to 5.
More
And then
like
obesity was about 10% more likely, and then sleeping less than 9 hours a day was about 8% more likely.
Yeah, for every single year before age 12
Okay.
that they had a smartphone. That's awful.
Yeah.
Although, what I would like to know is, what's the correlation between those 3? Because if you're not getting enough sleep, obesity and depression follow on that. Yeah.
And basically, this is me extrapolating, right? If they were sleeping less than, if they had the depression, they were sleeping less than 9 hours. If they had the obesity, they were sleeping less than 9 hours, is what it looks like to me. Because it's the
Right.
most common thing.
Right. Unfortunately, with the data as they have it on this, we can't see.
Yeah, how many hit all 3, how many hit 2.
Right. Yeah, probably not many.
And last, in analysis 3, what we found is that when we only look at kids who by age 12 did not have a phone, more than 3,000 of these and 4 of them a year later into age 13. During this year, around half of the sample acquired a phone, and this half of the sample showed more psychopathology, screen cuts ratio, and more insufficient sleep compared to those who did not acquire a phone. And what's important about this model is that it also accounted for the baseline age 12 psychopathology of sleep, which strengthens confidence that the findings are related to smartphone acquisition in the past.
Okay, so what are you seeing in the graphs?
So people who received a smartphone within the last year,
They looked at people who didn't have one at age 12, but did at age 13. And he said it was half of the remaining group. So you basically are taking a group of around 3,700 people. And now the only group that's remaining that doesn't have a cell phone is 1,800 people out of 10,000. So 82% by age 13
had a phone.
had a smartphone. And this just looks at the outcomes of the people who acquired it between age 12 and age 13 compared to people who didn't.
It shows that their risk of everything went up.
Immediately.
But the variance on the obesity is a little out there for the adjusted obesity, which I guess is probably hard to say within a year.
Oh, okay, sure. Yeah, obesity is a thing that tends to creep up on you.
Yeah. Their bar for variance goes down to 0 and past 3.
Okay. But overall, when you look at the depression and the insufficient sleep,
Yeah, insufficient sleep is highly confident in it's about 60% more likely.
so just acquiring a cell phone between age 12 and 13 increases the risk of getting insufficient sleep by 60%.
Yeah.
Wow.
And then depression diagnosis, when adjusted, is even higher, like 65, 70.
Oh my gosh.
And then the obesity was even higher than that, where their point is, but their variance was wild on that one.
Okay. Gotcha.
You ready?
To summarize, smartphone ownership in early adolescence is associated with poorer health outcomes, including depression, obesity, and sleep. The earlier that the kids acquired the phone, the more it was associated with poor health outcomes, particularly obesity and insufficient sleep. And lastly, recent acquisition of the phone between the ages of 12 and 13 is associated with poorer mental health and poorer sleep quality. Thank you.
I was wrong in my prediction. They didn't label a single benefit, but also I don't think the study was holistic. Because to be honest with you, you'd rather have a fat, depressed, insomniac kid than a dead kid.
Okay. So are you thinking that by not having a phone, you're so isolated?
No, I'm saying like parents who buy a phone for their kid, they're usually like, their risk mitigation is avoiding the worst outcome, which is
Oh,
death
sure.
of the child in an
In case there
emergency,
is an emergency.
and they can't contact anyone.
Okay.
Which, if you look objectively at the data, the odds of your kid dying are pretty stinking low. And the world, like violent crime wise, is the safest it's ever been.
Right.
So you could make the statement just based on the data that hardline, you just shouldn't give them a phone until some X age, something beyond 13 years old. But you got to factor in that parental brain, because you'd rather have a fat, depressed, insomniac kid than a dead kid.
Okay. So what you're saying is that you're trying to balance a catastrophic outcome with just a very bad one. So where would you, like if you were responsible for an 11-year-old or a
Okay.
12-year-old, and they're saying, I want a phone, where would you strike that balance?
Well, you've seen how I deal with things that want something from me,
Okay.
but I have an end goal for them.
Same way you deal with the cat, huh?
Yeah. But then again, the cat can mess with my sleep and everything. With the cat, I'm trying to get him to lose some weight. He's 16 pounds right now, down from 30. But he is a very persistent. Yeah, cats are, toddlers with the capability
Yeah.
to reach the
Very single-minded.
to food. So I basically give him no variance on it. Yeah, I'm extremely strict with his diet because I know that he is capable of working outside of the diet I give him. Right?
Okay.
And I know he does it. So I'm actually planning for I'm planning for some failure here when it comes to him
Okay.
by being stricter on the food I give him.
Okay.
Because I know he'll figure it out. He'll figure out somewhere to get food. I know I'll make a mistake. So with the kid, I'd like to say that I'd be able to hardline him,
Okay.
but it's actually pretty hard to hardline a kid, and because they're resourceful too, right?
Sure.
Well, you can go to Walmart or Target and get a phone with a plan, for like $150.
Okay. But how many 12-year-olds have $150?
Yeah, that's true, right?
So should you treat a cell phone then like a vehicle?
Wait till they're 16. Right?
Because we recognize that cars are very useful. We also have to recognize that they're the deadliest thing, like
For a teenager,
deadliest thing for all of us.
it's like the number one accidental death.
And it's basically the number one cause of death for people between the ages of like, I believe it's between 13 and 60. It's basically vehicle accidents
Okay.
are the single largest killer.
And you wouldn't be able to have a job for most of the U.S. if you don't have a car.
But it's also extremely dangerous. It's dangerous for a teenager.
And then, like a teenager with a job, how are you gonna tell a kid, yeah, you can have a job, but outside of work you can't contact them? So yeah, it's kind of rock and a hard place situation. What you can do is, even though carriers are making it harder to own dumb phones, there are phones out there that are specifically designed to work on modern carriers that have extremely limited capability.
Okay.
And
So if you're going to get a phone for your kid, get one with limited capabilities.
I'm saying it's an option.
Okay.
I'm not really out here to tell any parent how to raise their kid. But me personally, I've never had a kid, but that's what I would do.
Okay.
That's what I would do, is I'd give them one of these phones. Like, there's some that basically look like a Kindle. Like the screen is the Kindle screen where it's electrostatic.
Okay. Sure.
Yeah.
Okay.
And it has basic internet access, but it doesn't have a chip powerful enough to run like a regular app. It's basically good for some basic text-based browsing, phone calls, text messages. But then SMS is so unsecure. When you do two-factor authentication with SMS, it's actually possible for someone to intercept, because it's not encrypted, to intercept
sure.
that signal going to your phone.
They'd have to be pretty,
Savvy.
yeah.
But if they're not just doing it to one person and you have greater than $10,000, that's worth it.
Okay.
And they're not doing it for the one time.
Okay. So are you saying as a matter of security?
It's kind of worth it to have access to one where, yeah, you can encrypt it. Yeah.
Okay.
Yeah, protecting your financials is worth having a phone that's capable of running.
Encryption. Okay.
Yeah.
But that basically would mean you have to have a smartphone.
Yeah.
Okay.
So it's really a difficult problem.
So you also mentioned that if everybody else has a phone, then you're kind of the odd man out if you don't. So you get this sense that you're isolated. But then the phone itself is isolating. So when I was growing up, like, I was basically too poor. I didn't have video games. And I was always like, man, I wish I had video games like everybody else. But when you're sitting there playing video games by yourself, you're isolated. The thing is, though, people would go over to each other's houses and play.
That's the issue with the culture, is like it's basically entirely isolated from each other. But when you take communities that are linked well together but too poor to afford something like a smartphone for their child, right? What do we see at the apartments over here on the weekends when the weather's decent?
The kids are outside playing.
Yeah, because they ain't got a smartphone.
Yeah, but if you go over to the park there, like the people who don't live in the Section 8 apartments, it's almost always people walking over from the apartment building.
Right, and then even when they're not at the apartments, the people we see riding their bikes, they're from the Section 8 apartments.
Yes. And they'll be riding down the street and they'll happen into another one. They'll see each other and they'll start riding together very often.
What kind of isolation do you prefer?
So is there a certain point where having money isolates you? Okay, if you take like lottery winners or people who sell a business and suddenly become very wealthy, they'll tell you, like, they become very isolated. They become very lonely because, first of all, a lot of people that they knew suddenly always want money from them. The other thing is it's hard to make new friends because now, how do you know who you can trust? How do you know who's just being nice to you because they want your money?
I mean, yeah.
Right. And then we live in a litigious society, so is if I'm nice to this person, then something happens, are they going to sue me?
Okay.
Is it now down all the way at the point where you can afford a smartphone? Is it now all the way down to where just being middle class is itself isolating?
That's an interesting question. The next is my stuff. Let's see. All right. So this week, I wanted to cover how Ozempic and other second generation GLP-1 agonists might help with overcoming addiction.
Okay.
And to do that, first you got to understand kind of how GLP-1 works. So
I'm all ears. Actually,
okay, so GLP-1 stands for glucagon-like protein.
Okay.
And so when you eat, your gut detects that there's food, right? Your gut releases GLP-1, tells your pancreas to release insulin. And the GLP-1 in your blood travels up to your brain, and your brain has GLP-1 receptors that then begin mitigating your desire to eat.
Okay.
And since 2005, GLP-1 agonists have been used to help treat type 2 diabetes.
Okay.
Because basically, if you're just treating with insulin and you're not going after the behaviors, right? You're just kind of...
So basically what you're saying is if you just treat,
You're only treating the symptoms.
you want to get at the root cause as much as possible.
Yeah.
And the root cause in this case would be what?
Overeating.
Oh, obesity.
Yeah.
Okay.
Well, it's used in type 2 diabetes. It was originally used in type 2 diabetes with patients who couldn't get past their cravings.
So the idea is reduce the cravings, reduce the desire to eat.
As well as treat with insulin.
Okay, gotcha.
And that's how Gen 2 works as well. But it works so well that they're actually using it as a preventative measure for people who are tending towards that direction.
Okay.
From what I read, you really don't want to use it unless you really need it.
As in, if you have food cravings that you simply cannot ignore.
Yeah, if you're pre-diabetic, it makes sense to use.
Okay.
But if you're just trying to lose the 10, 15, 20 pounds, it really fucks up your gut when you do it.
Really? Okay. So how does it fuck up your gut?
Causes like constipation, it causes...
Oh.
It makes you nauseous. It's just, it wrecks your appetite, but it doesn't do it pleasantly.
It's not a cost-free.
Yes. And a lot of people who lose weight with it, like their face sinks in, everything like that, they look like they're on the crackhead diet.
Okay.
It's because, really, that's because they lose the weight too fast. But when you're extremely obese, there's no such thing, I think.
Sure. The thing is, though, if it's giving you constipation and everything else,
Yeah.
like that alone is going to make you not feel like eating.
The problem with GLP-1, as it naturally occurs for people, is its half-life is 2 minutes.
Okay.
So it's really just supposed to be a kickstart to your pancreas to get it to release insulin. And then your brain's a little more sensitive to it.
Okay.
So that lasts a little longer. But it just gives you that initial stop signal to eat.
Okay.
After that, it goes under cognitive control.
Okay.
So it stops the emotional desire, but not...
Okay.
Yep. So that's why GLP-1 kind of generation 2. And like, when I refer to generation 2, I'm talking about like Ozempic, tirzepatide. The one in the study that I'm going to talk about is a Gen 1 called dulaglutide.
Okay.
And so, that's how GLP-1 works.
Okay, gotcha.
Anyway, anecdotally, right, people have been saying when they're taking these Gen 2s that they're actually losing their desire to keep smoking.
Okay.
There was an anecdotal story that kind of sparked all this for me when I was looking for it, the thing that popped up. He actually had seen, there's a more recent study that came out in 2025 where it actually helped alcoholics. It was used to study how GLP-1 agonists help people quit drinking. But that's not the particular study that I read. The one I read was helping smokers stop smoking. And they used a Gen 1 GLP-1 called dulaglutide. Dulaglutide.
Okay.
And in this particular study, they didn't find that it helped with the behavior. But when people are quitting smoking, they actually usually gain some weight, right?
Yeah, because nicotine's kind of an appetite suppressant.
Right. They actually, when they're initially quitting, there's a significant risk of going pre-diabetic and then
Really?
long-term going diabetic.
Huh.
Yeah.
Wow. Okay. I did have a teacher, I think it was my health teacher in, I don't know, middle school, maybe high school. She said what it is when you smoke, basically the hot smoke deadens your nerve endings. So it's actually when you quit smoking, things taste better.
Oh, interesting.
So it makes you want to eat more.
Well, in this study, the reason that they were giving people who were trying to quit GLP-1 agonists is actually to help prevent the weight gain.
Okay, sure. It was a prophylactic measure.
Right.
Gotcha.
Because a lot of smokers, cigarette users, will say they don't want to quit because they don't want to face the weight gain.
Sure.
And actually, for a lot of people, quitting the smoking actually fucks up their health more when they get obese.
Okay. Believe that.
And
Especially if getting heavier then makes it harder to move. It gives you more joint pain.
so in this study, it was a 12-week study. They gave the control group, they injected the control group with saline,
Okay.
and then, but also the other pharmacological aid, both groups got the pharmacological aid. It was the medicine I told you about earlier.
Chantix, the chemical name.
Yeah, you mind Googling it real quick?
Okay.
Starts with a V.
Varenicline.
Varenicline. Okay. So they gave patients here, they gave them a control group saline, and they gave the experimental group dulaglutide. They both got therapy that helped them change.
Okay, so like talk therapy?
Yeah, and they got, I believe it was cognitive.
Okay.
And then they also got a co-pharma, right? What is it?
Nicline. Yeah.
So they really tried to give them the best possible.
So varenicline is the generic of Chantix.
Yes,
Gotcha.
varenicline is, yeah. They gave them varenicline and therapy to help them quit smoking.
Okay.
And they actually didn't let the doctors or the therapists know that these patients were receiving dulaglutide.
Okay.
I think they knew that they were part of a study. Well, they would have to because of who their employer would have been, right?
Mm-hmm.
But they did not know. Well, I believe what they were told was they shouldn't really affect each other.
Okay. Gotcha.
But obviously, if someone got like really sick, they would have been. Luckily, no one got really sick during the study.
Right.
But
Sure.
and basically, what I found out is that quitting smoking is actually really harrowing for a lot of people.
It's
83% of the control group, the one that did not receive the GLP-1 agonist, 83% of them reported gastrointestinal issues as they were quitting.
so even the people who were receiving placebo, gastrointestinal issues when they quit.
So 25% of everyone from both groups already had gut problems coming into it.
Okay.
And then the first 4 weeks, 83% of the control group reported gut problems, and 90% receiving the GLP-1 agonist. And the GLP-1 agonist people had way worse nausea
Sure.
and way worse constipation.
Okay, you're good.
Yeah, so 114 out of the 127 GLP-1 agonist users reported moderate to severe. And then
Man, that's rough.
and the control group, 81%, so not 83%.
So with those GLP-1 agonists, it's not just the first generation was difficult, like even Gen 2.
Yeah, it does not make you feel good,
Okay.
which is kind of part of the method of action.
Feel like eating. Okay. Let me set up the lights because I think we're going to run out.
Okay.
Oh, man, that died quick. Hopefully this other one wants to stay on. We will find out. This is also dead. Didn't take long. Okay.
I need 1 minute.
Okay.
Interesting.
That I don't like.
Do you have it on full blast? Turn it down a little? Huh. Other one's doing it too.
It's all right.
You know how I know to turn it down a little?
Huh.
The jet does the same.
Really?
How do I remove a text box?
From what?
A slide?
Oh, you just right click. Okay. So here's what I want you to do. Go right click on that right hand column, on the left hand column where you can see all the slides. The slide you're on. Okay. Let me assist. Okay.
I need a slide. Thank you. What? God damn it, dude. I managed to make the UI disappear. Can you help me?
Yes. What are you trying to accomplish?
Trying to get it to present.
Oh. All you have to do is hit escape.
Okay.
Okay. All right. Here we go.
Okay. So, one thing I want to make clear is like just how ethical this study was.
Okay.
Basically, what they gave the patients the best possible treatment.
Okay.
Typically at 12 weeks, it's 50-50 whether or not someone quits. In this particular study, both groups were well above average. The placebo group actually had a higher success rate at 65%.
Okay.
And then the GLP-1 agonist group was 63% at 12 weeks.
Okay.
And it's because that they did the therapy and the pharmacological approach.
Okay.
And anyone who did not come back to the study later, they counted as a persistent smoker.
Okay.
So,
So people who just didn't respond, they assumed they kept on smoking.
yeah. I mean, like, why else would you not
Okay.
respond and come back? And so at the 12-week mark, what they did is they didn't just take the patient's word for it. They also measured how much nicotine was in their urine
Fair. Okay.
and blood, and they measured how much carbon monoxide they were exhaling. Basically, persistent smokers, when they exhale, you can actually say for certain that someone is a smoker. It's indicative of smoking when they exhale more than 10 parts per million.
Of carbon monoxide. Well, what it is carbon monoxide actually sticks on to the hemoglobin much more strongly than oxygen does.
Okay.
So it releases, but it's slow. So you smoke a cigarette now, 2 hours later, that carbon monoxide is still slowly leaving your body. So that's part of the reason why smokers have a smaller oxygen transport capacity. It's because they are always carrying a burden of carbon monoxide,
Gotcha.
right? And yeah, that's actually one benefit you get from quitting is within 48 hours, that carbon monoxide level in your blood has dropped back down to normal.
The reason why they counted everyone who did say they quit is because they did reduce. And the other thing is, some of them quit like towards the very end of the study.
Sure.
And I'm pulling up the numbers now. So, abstinence with the stricter definition, negative urine creatinine level at week 12 required additionally was reached in 59 out of 127 with the dulaglutide and 64 out of 128, 50% on the placebo side.
Okay. Well, that's actually still a pretty solid success rate. 50%.
And the other thing is, one of the prereqs to join the study is that you had to want to quit.
Okay.
And that's the truth in any addiction, is that you can't force anyone to quit anything.
Yeah, that's true. Mm-hmm.
You have to, the cognitive side can also influence your emotional side.
Sure.
If you go into a treatment never intending on quitting, you will never quit.
So is what they're saying just giving people the GLP-1 agonist increase the quit rate to 50%? Okay.
Because that was the placebo group.
Okay.
So this particular study did not err on the side that GLP-1 agonists help with addictions.
Okay.
But this was a Gen 1.
Okay, gotcha. It doesn't stay around as long.
This here is Sue Grigson.
Okay.
Sue Grigson has actually been doing research for years. She's been saying for years that these GLP-1 agonists may actually help with people kicking their addictions.
Okay.
Just recently, she received an email from a fentanyl addict
Okay.
who said they had read a study that GLP-1 agonists, Gen 2, helped rats with their addictions.
Okay.
Like they did a study, they got rats addicted to, I believe, cocaine, heroin, and fentanyl.
Oh my gosh. Okay.
Like 3 separate groups.
It's a tough life for lab rat, man.
Yes. And then they treated them with GLP-1 agonists.
Okay.
And then that was shown to have some success.
Okay.
Right? In fact, I believe with the nicotine, they also did nicotine. It completely switched off the reward system for nicotine.
Really?
Yeah.
The GLP-1 agonist did. Okay.
And then currently there are multiple studies that, like first round clinical studies that will have data coming out in the beginning of 2026.
Okay. And these are human studies. Oh, cool. Okay.
So while I don't really have an article to feature where it supports these,
Get data next
Yes.
year that'll help us see either way.
and another point of focus that I wanted to put out there is that these GLP-1 agonists, they're not the wonder drug that they have been advertised as. They are very costly on the body. It is not a fun experience. If you can manage your weight behaviorally yourself, you do not want to use these things.
It's way better off. Okay.
That said, it is so much better to lose the weight.
Okay.
Yeah.
Because the cardiovascular effects, the inflammation that just comes along with.
Well, from being obese all your life, it's going to wreck you, right?
Yeah, it definitely takes a lot out of you.
That was mine.
So do you recognize this?
Yeah, we covered this
Yeah.
where we covered life on Mars.
Yeah. So you see the Acetus Basin, right? And the Jezero crater. And if you go to the next slide, it'll zoom you out a little. Okay. And you see where it says Utopia Planitia? Utopia, the Utopia Basin. And we are going to go up into there. If you go to the next slide, we are going to this area here called Hebrus Vias. Hebrus Vias. And the reason we're going to talk about this is because there are some interesting little pieces. There are some interesting little things that have been observed up there. Now, first I want to talk a little bit about karst caves. Karst. So karst is, if you go to the next slide, karst is basically, it's, for the most part, it's calcium carbonate and other sulfates. So it's carbonates and sulfates. And when you run water through it, water naturally dissolves some carbon dioxide into it. So you can get this very slightly acidic heat just from rainwater, or even just water that's running in a river. It's going to naturally absorb some CO2.
Produce some carbonic acid.
Exactly.
What makes your water stale when you leave it out overnight?
It's CO2.
Yeah, it's the carbonic acid that makes it taste weird.
Now I know.
That's why soda water is so unpleasant, where it's just carbonated water. It's because of all the carbonic acid. It does not taste good to you.
You know what? I actually enjoy drinking just straight up soda water.
Most people don't.
Anyway, when that water runs through these carbonates and sulfates, dissolves some of them, right? And so you get little channels. And these channels become larger depressions. And what can actually happen is underground, it's continuing to dissolve these sulfates and carbonates. And so you wind up with a cavern underneath. And then the ground above can collapse into it. And so you wind up with these karst landscapes, K-A-R-S-T. And you can see in the right-hand corner, eventually those depressions kind of grow in, right? But you'll always have visible within the landscape. You'll be able to see that it's depressed like that. You just have these areas of depression. And that's called a karst landscape, okay? If you go to the next slide, you can see kind of what one looks like from above. If you look at that grassy field, you have all these little caverns that have collapsed. You can see on the right where you're kind of like in this cave. You're in this cave, this cavern, right? But the opening is collapsed. So you have kind of a bigger opening, okay? If you go to the next slide, so these are called skylights, Martian skylights. And these particular skylights were photographed by the Odyssey orbiter. And so you'll notice you have one side where it's kind of lit, and then another side where it's completely shadowed.
Yeah.
Right. So you can see the big ones there.
Oh,
Those are
okay.
impact craters. But then you have these smaller ones that they're darker. They have like a smaller part that's light, that's reflecting light, and a bigger part that's completely shadowed.
Okay.
That part that's reflecting light is where you still have some surface covering. And where it's completely shadowed, it's where you have a collapse. And those skylights, for the most part, have been believed to be basically created by the lava intrusion underneath. That lava intrudes in, melts down some of the sediment or whatever's on top, right? And then you wind up, that sediment and everything kind of sinks down into that lava, and you wind up with this depression underneath the ground. And then the surface above it partially collapses.
Okay.
Right? And so you get this skylight. And if you go to the next part, it gives you more of a breakdown of that, where you have the shadow part, the illuminated part. And if you look at the impact craters, you can see where there's ejecta and little rays coming off of it. While with the skylights, there's no ejecta or rays. Do
Okay.
you see that?
Yeah.
So looking back at Hebrus Vallis, or Hebrus Vallis, this is what it looks like. This image.
Which one?
Go down to the next one. This is a zoomed in image of what the channels in Hebrus Vallis look like. So you have this elevated kind of volcanic region.
Okay.
And then you have this area where water in the past flowed down through it. And it's believed that these water flows occurred in the early Amazonian on Mars. So the period after the late heavy bombardment, after you had all these impact craters, after you had this period of heavy cratering, you then had this time where there was some water that could basically be melted by volcanic activity or perhaps by a smaller impact, right? And that water would melt and then run down in these channels. So if you go to the next slide, this is the study I looked at. Water-driven, accessible, potential karstic caves in Hebrus Vallis, Mars. Implications for subsurface habitability. Now, the little stars there are the caverns, are basically the skylights they looked at, the features they looked at. And you can see all along through there, you can basically see where the channels are.
Okay.
You see that?
Yes.
You have basically all these little blue, that they deliberately made the low elevation points blue, but you can see where you have basically little streams and lakes
Yeah.
that would have existed 3 billion years ago on Mars. If you go to the next slide, these are photos of those 8 starred items, right?
Okay.
And they're numbered 1 through 8, 1, 2, 3, 4 up top, 5, 6, 7, 8 on bottom. They show the locations again in the middle. And on the right, I have magnified out number 1.
Okay.
So you can see where there's a deep depression
Yes.
coming off of it. And if you go to the next slide, this is the elevation map of that hole, SK1. And you can see how you have this depressed area, and then you have a sudden very deep depression. What this shows is that you had this area that was, what they believe is that this is evidence that this was all cleared out by water. And then you had a collapse, like a further collapse into the ground of part of it.
Okay.
So this whole depression was created by weathering. And then their argument would be that water actually percolated downward further, dissolved some of the rock underneath, and then that particular part of the hole collapsed even further into the ground.
Okay.
On the next slide, this is a map of sulfates up top and carbonates on bottom. And these were found by spectral analysis, right? And so you can see in that area where these caves are, there's an increased amount of sulfates and carbonates,
Okay.
which are what would dissolve to produce like a karst landscape. And if you go to the next, this is a map of hydrogen. Basically, if you have water running through all these minerals, it would leave behind some hydrogen.
Okay.
Some of those water molecules might stick, or OH molecules, or whatever, right? So you would expect to find an increased amount of hydrogen. And that's what you see. They also say that it could be a sign that there's subsurface water, like frozen in the ground. But of course, until you get something down there, there's no way to do it, right? Now, on the next slide, this is actually a very large karst cavern, Mammoth Cave National Park.
Oh, really?
And you can see actually with the image on the lower right,
They put a national park on Mars?
they will go. But you can see that you don't just have a cave, you have a whole cave system
Okay.
where water is intruded through and it's basically percolated through the ground and weathered out all these caverns. And what these researchers are proposing,
Didn't we go to Mammoth Cave?
we went to Wind Cave.
Okay.
What they're proposing is basically this, that you have this river channel that delivered all this water through the early part of the Amazonian. And it could have only been 1,000 years here, 1,000 years there. Just that you have water that's going down, weathering out these little holes, getting captured in there, and they're percolating down into the ground. And what they're proposing is that there's a possibility this water is still captured underneath there. And that would create the potential that if you were going to look for life on Mars,
That's where you would look.
yes. And so they believe that what should be done in the future is rovers should go to caves like this.
Okay.
Now, there's another study I looked at, if you go to the next slide. Large drainage systems produced half of Mars' ancient river sediment. Now, this first map is actually Earth. You didn't know that, did you? But those are drainage river systems. And on Earth, drainage river systems go out into the ocean.
Okay.
And you can see it's basically all around the edges of all the continents. Doesn't completely cover all the edges.
Yeah, the U.S. East Coast doesn't have any.
Fair. But if you were to look at what percentage of the world's fresh water drains into the ocean, you would find that if you added up all these points, you're getting close to 85, 90% of the fresh water on Earth that drains away. The liquid fresh water, right? Because the majority of the fresh water is frozen over Antarctica and Greenland. Now, if you go to the next slide, one critical difference between Earth and Mars is that on Earth, first of all, you have all this organic material. And secondly, you have these spread out floodplains. And if you look at the bottom, you can see the elevation graphs and the distance.
Okay.
So you can see on Earth, it's a quick drop off in elevation.
Right.
And then the water spreads out into the floodplains and eventually out into a delta, right? While on Mars, you just have this steady drop where it's moving from basically where you have a change on Mars, it's where you basically have a crater. It goes from one crater to another. Like the Martian landscape is basically a landscape of craters and volcanoes, right? The next slide is a map of Mars. And this is a map, their proposed map, of where the drainage basins are, of where basically where you have drainage channels going out to basins, right? And if you look at the next slide, keep this one in your mind. This is a map of where skylights have been identified. And if you go up to the previous slide and you compare the two, you can see that where you have those drainage areas are also where you have the most identified skylights.
Yep.
A definite correlation between skylights and drainage areas.
Interesting.
So the most accepted paradigm is that Martian skylights are mostly created by lava pools, by subsurface lava that kind of melts out this sediment
Okay.
and leads that sediment to collapse. But this other proposal is that those skylights could actually be a result of water dissolving sulfates and carbonates. And when you look at the drainage map versus the skylight map corresponds a lot better with that idea. Maybe the majority of these skylights are not created at all by
Magma.
Right. They could actually be a result of these drainage systems, in which case it's almost like take your pick. It would be a great idea to drop down a rover in an area where there's lots of skylights and see if it can maneuver closer to them and get a good look down into them. The problem, though, is if it actually goes into one, how do you ever get it back? Like, how are you going to get signal out of there?
Yeah.
Could still be lava. Yeah. But if you were going to look for life on Mars, now, I think the chances you'd find life that's still alive or liquid water still in there, I think that's basically,
You're dreaming?
yeah.
Yeah, I think if it's exposed to the atmosphere at all.
We know from our previous episode that I believe that the evidence that there was life on Mars at some point is just,
Yeah, it's irrefutable.
yeah. So I think it would be worthwhile I kind of agree with these authors that it'd be worthwhile to send the next rover to check out some of these subsurface.
How thin is the Martian atmosphere.
It's my understanding it's 1% of what Earth's
Whoa.
is.
I don't know what to do then.
And it's almost entirely carbon dioxide.
You could get something that goes down there, collects, and then basically fires a rocket to get itself out.
I would have to do something like that.
Because initially I was thinking like almost like a drone, but if it's 1% as thick, I don't even know that a fan blade would be able to be spun fast enough to lift itself.
So they're part of the Perseverance rover was a helicopter.
Really?
Yeah, look it up. Look it up. Like, just type in NASA Mars helicopter. I don't think it works anymore, though.
Yeah.
Get us some info, dude.
Ingenuity, nicknamed Jenny.
Okay.
It's an autonomous NASA helicopter that operated on Mars from 2021 to 2024 as part of the Mars 2020 mission.
Yeah. It was basically like a little drone, like you were describing.
This is what we're up against.
What can you tell us about Ingenuity?
I can tell you Wikipedia needs some money.
Yeah, they're always under fire, man.
Flight is possible in the extremely thin atmosphere of Mars, and becoming the first aircraft to conduct a powered and controlled extraterrestrial flight.
Right.
It was designed by NASA's Jet Propulsion Laboratory in collaboration with AeroVironment, NASA's Ames Research Center and Langley Research Center, with some components supplied by Lockheed Martin. Ingenuity was delivered to Mars on the 18th of February 2021. My mind actually confuses February and April.
Really? Why is that?
Beginning of the year, that's all I...
Huh. Okay. Sure. That could be it.
Well, no, I know that's it. But
Okay.
that's the thing, and it doesn't make sense to me. It's done that since I was like 5 years old.
Really?
Since I learned months.
Okay.
Attached to the underside of the Perseverance rover, which landed at Octavia E. Butler Landing near the western rim of the 45-kilometer wide Jezero crater. Because radio signals take several minutes to travel between Earth and Mars, it could not be manually controlled in real time, and instead autonomously flew flight plans sent to it by JPL.
Oh, okay. I see. So what you would have to do is you'd have to have a rover with another little helicopter. But then you have to plan out a whole route for it into one of those caverns and then back out. Now, that's a pretty tall order. Just make it be an AI helicopter.
Oh, originally intended to make only 5 flights, Ingenuity completed 72 in nearly 3 years. What do you mean?
They were like, oh, yeah, we'll be lucky if we get 5.
Yeah, sure.
You know?
Well, it would make sense to say 5, because if you get 0,
I'm just saying they sandbagged that.
sure. They could have said, if they were being more transparent, they're like, we don't know the odds that it flies at all, but if it flies, I bet we could get a couple dozen out of it.
Sure.
Sure.
Well, it's just like... okay.
So they could have said, we have 0 expectations.
So in 1992, when Bill Clinton was running for the Democratic nomination,
Okay.
he absolutely got hosed in Iowa. He got wrecked. And people thought he was going to drop out. But then he basically stayed out for 3 days, just talking to every person he could in New Hampshire. And even the day of voting, he was out shaking hands in the snow, just trying to save himself. And basically, he said...
So he failed in Iowa and then went to New Hampshire?
And basically, his team said, we have to place in New Hampshire in order to be in this thing. We have to place. Well, he came in 3rd in New Hampshire. And he goes off and gives a speech about, we won, we did what we needed to do, we are in it. Thank you, New Hampshire, for making me the comeback kid.
Okay.
He came in 3rd. He basically lost New Hampshire. But his team, he and his team had sandbagged it so much that literally, if his name even appeared in the top 5, they were going to be able to call it a win.
Okay.
So they built a helicopter that could fly dozens of missions. I love that.
I don't really disagree with them.
I don't either. Right.
There's no way they could have anticipated cranking out 72 flights. Meanwhile, there's probably some engineer who was like, I built that thing to make 250 flights.
Right. Yeah. I personally think it's pretty much a feat that they were able to send that and land it and have it still work.
Yeah, oh, well, yeah. I kind of take that for granted at this point, but
Look at how much stuff we have that doesn't even survive shipment on Earth.
yeah, but that's because we're saving cost.
Well, they've become more effective,
Since-
cost-effective over time.
Well, yeah, they try to be cost effective with Challenger.
There were a number of engineering errors. There were a number of mistakes with
Right.
Challenger. But the biggest mistake with Challenger was that nobody wanted to not launch it.
They weren't doing proper inspections.
Yeah. And even the people who had said this is going to be a huge problem, they were ignored. That
No.
they used to. It's almost all unmanned, which honestly is probably better.
Right. It's not really good for people to.
Space is not a good environment.
No, not
know.
for. Yeah.
And when people talk about, oh, we should go to Mars, I'm like, y'all can go to Mars.
Yeah.
I'll be right here. Anyway,
There was something that I forgot to mention about nicotine addicts and their GPL1.
the GLP-1.
GLP-1. With GLP-1, when you are in active addiction, this was measured on cadavers
Okay.
who were nicotine addicts,
Okay.
but I think the likelihood that it applies to everything is pretty high that you get
Okay.
addicted to,
Sure.
like most drugs. The brain increased the number of GLP-1 receptors in their brain because smoking cigarettes actually damages the body's ability to produce GLP-1.
Really? Okay.
So the brain increases receptors to retain sensitivity to GLP-1.
Okay. And it works. Smokers, when they quit, tend to gain weight.
You don't want that. GLP
Right. But since they're producing a lower amount of GLP-1,
Quitting smoking helps their intestines recover.
so they're actually kind of going in the opposite direction. They have
but
more, and they're producing more GLP-1.
I think I was completely wrong about how long it takes for their intestines to recover.
Okay.
But that would help the intestines recover, though, is if you quit the thing that was damaging them.
Yeah, that's true.
But yeah, in order to retain sensitivity, their brain grows more receptors.
So then that would actually make the GLP-1 agonist more effective. Yeah. On that note, I believe the ideal life is a nonstop process of learning and growing. Thanks for learning and growing with us. Stay on your game, and we'll see you next time on Everybody's Podcast.
Oh, yeah.